Okay, this is the next lesson in Algebra 2. It's called Graphing Quadratics in Vertex form. The previous lesson was graphing quadratics in standard form. Now this is a different form. So this first blank just goes over the previous lesson. We call that the standard form of a quadratic function is f of x equals ax squared plus bx plus c. That's called standard form. That's what we did in the previous lesson. We graphed them in standard form. Okay. Now we're graphing in vertex form. So the vertex form of a quadratic function is f of x equals a times x minus h squared plus k. Now, h comma k, that represents the parabola. Okay? The h and the k represent the parabola. You have to be careful for the signs, as you'll see when we get to the examples. Okay? The h, you might remember this from Unit 2, Families of Functions. The h represents the horizontal shift, how far left or right you're moving from 0. And the k value, right there, represents the vertical shift, how far up or down the graph is shifted from 0. Okay? And here we go. Again, this kind of shows you what I just said. So this is vertex form. This h represents how far you're translating it horizontally. The k represents how far you're translating it vertically. And the a at the front represents whether you are reflecting it across the x-axis or not, and whether you have a vertical stretch or a vertical compression. Okay, so it talks about whether you get skinnier or wider. That's what the a represents. Okay, so let's do a couple examples before we start graphing. Example 1, A and B. First, identify the vertex, and then describe the transformations from the parent function f of x equals x squared. Okay. So first, let's identify the vertex. Okay. So again, the vertex is represented by h comma k. So in this case, the vertex is going to be 5, not negative 5. Okay, that's the vertex right there, 5 comma 7. So in other words, you take the opposite of whatever that sign is for the x value. Okay, so this is x minus 5, so the x value is 5. If it was x plus 5, then you would have negative 5 right there. So basically, it's the opposite sign of what you might think for the x. Okay, so take the opposite sign of that. But the y value is whatever the sign is, okay? So the y value is positive 7. That goes back to Unit 2. Remember when you had to shift it left or right? It's the opposite of what you might think. So now we have to describe the transformations from the parent function, x squared, okay? So this is being shifted 5 units to the right. So it's the parent function shifted 5 units right. The 7 means it's shifted 7 units up. And whenever the number at the front has an absolute value greater than 1. So for example, if the number in the beginning is like 2, 3, 4, 5, 6, 7, negative 2, negative 3, negative 4, negative 5, or decimals like 2.5 or 5 halves or 7 halves, then it's going to be skinnier than the parent function, and that's called a vertical stretch. I'm going to jot down vertical stretch. In other words, it's skinnier. Okay, let's try example B. The vertex first. The vertex is h comma k. Take the opposite sign of that. So it'll be negative 4, negative 1. Okay, we're taking the opposite sign of that number. So negative 4, comma, negative 1. Now let's describe the shifts from the parent function f of x equals x squared. This is being shifted 4 units to the left. Again, going left to right is the opposite of what you might think. So it's shifted 4 units left, shifted 1 unit down, the negative sign out front means it's opening downward, so it means it's reflected across the x-axis. So reflected across the x-axis. You can write that when there's a negative sign at the beginning. That was not the case in example 1a, but it is the case in example 1b. Reflected across x-axis. And since the number out front is a fraction between 0 and 1, or between 0 and negative 1, then it means it's a vertical compression. In other words, it's wider. Okay? Okay, let's move on to page 2, and let's do an example where we actually graph. Okay? Now, again, we're graphing in vertex form. So when you're graphing in vertex form, that means you can get the vertex easily. Okay? That's why it's called vertex form. So you should be able to look at this graph, this equation, I should say, and get the vertex right away. So what is the vertex from this problem? Think back to the first page. The vertex is -1, -4. It's called vertex form, so you should be able to get the vertex right away. And let's get the axis of symmetry right away. Because remember, the vertex is on the axis of symmetry. So if that's my vertex, -1, -4, then the axis of symmetry is just x equals -1. So let's graph each of those. Dashed line for the axis of symmetry. And let's plot the vertex on that line. So -1, -4. Right there. Okay. So we got our vertex right away. We got our axis of symmetry. Let's get some additional points and reflect them. And let's try to get 5 points total on the graph. So let's get an additional point. How about we choose x equals 0, because that'll fit on there. Let x equal 0. So let me just copy down the original problem. Y equals 2 times x plus 1 squared minus 4. And let's substitute 0 in for x. So y equals 2. We're choosing x equals 0, so 0 plus 1 squared minus 4. And you're just going to follow the order of operations and do it slowly, that way you don't make any careless mistakes. Parentheses first. 0 plus 1 is 1. So y equals 2 times 1 squared minus 4. Okay? Now be careful. We're not multiplying next. Okay? You're doing the exponents next. Okay? 1 squared is 1. So it's y equals 2 times 1 minus 4. 2 minus 4 gives you y equals -2. 2 minus 4, y equals -2. So that means we have the additional point. We have 0, -2. So let's graph that, and then let's reflect it. 0, -2 is right there. That point is 1 unit to the right of the axis of symmetry. So let's go 1 unit to the left of the axis of symmetry and plot a point like that. Let's do one more additional point and reflect that. So how about we do x equals 1? Let's let x equal 1. I'll copy down the original problem. And let's replace, or let's substitute 1 in for x. So y equals 2 times x is going to be 1 plus 1 squared minus 4. And now order operations. 1 plus 1 in the parentheses is 2. One step at a time until you're comfortable, okay? Don't do the multiplication next, so don't do 4 squared is 16. You got to do the exponents next. 2 squared is 4. Two times 4 is 8. Y equals 8 minus 4. So y equals 4. That means we have the point 1, comma 4. Let's graph that. And then reflect that across the axis of symmetry. That's 2 units to the right of the axis of symmetry. So let's go 2 units to the left of the axis of symmetry and plot a point and connect it. There we go. Okay, I've got 2 more examples today in these notes, so I'll go through them a little faster because we just did one. Not too much faster. Example 3, again, this is vertex form, so start by stating the vertex. The vertex is 2, comma 3. Take back to the first page. The opposite sign of what you might think for the x. So 2, comma 3. Which means the axis of symmetry is x equals 2. Whatever that number is. I think I like this way better than the previous lesson. It's just so easy to get the vertex. So let's plot the vertex and the axis of symmetry. Let's do a dashed vertical line at x equals 2, because that's the axis of symmetry. Boom, boom. Let's plot the vertex at 2, 3. Now let's get some additional points, and we'll go from there. So I'm going to pick x equals 0 for my first additional point. I'm going to try to avoid fractions. I'm going with x equals 0. Okay, so we have our vertex, our axis of symmetry graphed already. Now I'm getting some additional points. Let x equal 0. And let me recopy down the original problem. And let's substitute 0 in for x and simplify. Parentheses, 0 minus 2 is negative 2. Next up will be the exponents. Negative 2 squared, be careful, is positive 4. So y equals negative 1/2 times positive 4 and then plus 3. Negative 1/2 times positive 4 is 2. I mean negative 2, negative 2. Y equals negative 2 plus 3, which is 1. That means I have the additional point 0, comma 1. Let's plot that and reflect it. Again, you should know ahead of time this graph is going to open down because of that negative sign at the beginning. So we have the point 0, 1. And then reflect that across the axis of symmetry right there. And let's do another additional point. Okay. So for my next additional point, again, I'm going to try to avoid the fractions. I'm going to go with x equals 6. I'm going to choose x equals 6. That's going to be my next additional point. Let x equal 6. By doing that, I know there will be no fractions. So let me just recopy down the original problem again. And let's substitute 6 in for x, and then order operations. X is 6. Parentheses next, 6 minus 2 in the parentheses equals 4. Next to the exponents, 4 squared is 16, so negative 1/2 times 16. Again, I'm just doing one step at a time. That'll be negative 8 plus 3, which is negative 5. That means I have the additional point 6, negative 5. Okay, so that's my additional point right there, 6, negative 5. Let's graph that, and then let's reflect that. 6, negative 5. Okay? So if you look, that is 1, 2, 3, 4 to the right of the axis of symmetry. So I'm going to go 4 to the left of the axis of symmetry, plot a point, and let's draw our parabola. Remember, these should be U-shaped, not V-shaped. V-shaped is the absolute value family of functions. There we go. All right, one more example in this lesson. I'll go a little quicker through this last one. Start by getting our vertex, okay? So again, 4 comma negative 2. The axis of symmetry would be x equals 4. X equals 4 is the axis of symmetry. Let's graph the axis of symmetry and the vertex now and get that over with. There we go. Axis of symmetry is x equals 4. Vertex is 4, negative 2. All right, let's get some additional points. I'm going to go with x equals 2. That'll be my first one. I'll go with x equals 2. You don't have to choose that, but I know that's going to avoid fractions. I'm going to recopy down the original problem again. Y equals 1/2 times x minus 4 squared minus 2. And then replace the x, or substitute 2 in for x. Two minus 4 in the parentheses is negative 2. Negative 2 squared is 4. Positive 4. 1/2 times 4 is 2. So y equals 2 minus 2. Y equals 0. Which means I have the additional point 2, comma, 0. Okay? Plot that and reflect it. 2 comma 0 right there. Reflect that across the axis of symmetry to get right there. And now let's do one more additional point. Let's go with, how about x equals 0? Let's do x equals 0. Additional point, let x equal 0. Copy down the original problem again. So 0 minus 4. Order operations, 0 minus 4 is negative 4. Again, try to go slow through these, don't rush. Negative 4 squared is 16, so 1/2 times 16 minus 2. Be careful for the signs. Negative 4 squared is positive 16, remember. 1/2 times 16 is 8, so we have 8 minus 2, y equals 6. Which means I have the additional point 0, 6. So let's plot that and reflect that. 0, 6. Reflect that. Go 4 to the right. And there you go. And then connect your points. And that's our graph. So the last lesson was graphing quadratics in standard form. And this lesson was graphing quadratics in vertex form.